Is that okay? Can we work on this 11?
Yeah.
Have you done it? Maybe you've done it. It says, and maybe I'll change it. It says, find the speed that this guy, find the speed in miles per hour that will minimize the total cost of this delivery trip. He called it, in your problem 11, it's a 140-mile delivery trip. Can I change it to a 300-mile delivery trip? Okay. Now, by the way, what might be helpful is distance equals rate times time. And rate is going to be what they're calling velocity. Is that okay with you? So the velocity v is my rate. I don't know what I could do with this. Well, so I'm trying to minimize my cost, and I've got two kinds of cost. I got the fuel cost per hour, Oh, and then I got to pay my driver certain wages per hour, right? So it's all, the total cost is going to be based on how long it takes him to do this trip. I need the number of hours. So I think I need time. What is time? Distance over rate, or distance over v. And what is the distance of this trip? There ain't no argument about
300.
It's 300. It's not a variable. So the time it takes for this trip is going to be 300 over v. And again, if he drives faster, it's a shorter trip. If he drives slower, it's a longer trip. Either way, it's a 300-mile trip. But if he drives faster, it'll take him shorter. But that's the time of the trip. Now, the cost is two kinds of cost. They've got the cost of the fuel. They said that's v squared over 400. Can I just change it to v squared over 500? I'm just changing it.
Why?
Just because you can do number 11 and I can do this modified 11. Okay? So you can do the real 11. I'll do the modified 11. This is 11 modified. So, wait a minute. This is the fuel cost per hour. So the total cost will be the fuel cost per hour times the number of hours I'm on the road. How many hours am I on the road?
300 over v.
Yes, that's the time I'm on the road. Plus his wages. I'm going to change his wages too. What's this guy get paid? $9.50? Let's pay him $15 an hour. That's what Bernie says. Pay him $15 an hour. All right. Or we could pay him $5.25. That's what Trump says. $5.25 an hour. All right, hang on. $15 an hour. And what's his? $15 an hour. And how many hours is he out there on the road?
300 over v.
Right. This is the key to the problem. Was kind of coming up with this idea. Because see, these times that these costs that they gave me were per hour. They gave me the fuel cost per hour, so I needed to multiply by the number of hours. And then they gave me his wages per hour. I needed to multiply by the number of hours. Mm-hmm. And by the way, you understand this problem? If he hauls ass and does this delivery trip and hauls ass and then I pay him less per hour. But he burns up a ton of gas if he's driving fast. So he should drive real slow to save gas. Well, then I'm paying him a bunch of money all day long, right?
Right.
So there's some balance. There's some speed he should go that would minimize my cost. There's some balance. But we created a beautiful cost equation here. Let's clean it up just a little bit. V cancels with this V, and if you don't mind, can I call that 3/5 V? Is it? It's 3/5, and this V cancels. It's 3/5 V. This is 15 times 300. That's a lot. 450. No. 4,500 over V. Thank you. 4,500 over V. Right. All right. Here we go. This is my cost equation we built. I want to minimize costs. What do you do when you missed a step. Take the derivative. That's right. That's key. You do the derivative and set it equal to 0. Right. I ain't done a derivative yet. Here we go. Derivative. The derivative is 3/5. That was easy. You know how to do this derivative? It's v to the negative 1, so you go negative 1, v to the negative 2.
Yeah.
So you get negative 4,500 over v squared. You guys remember? You move it up, you call it v to the negative 1. You do a power rule, you move it back down maybe. You know that, right? Cool, dude. Now you set this equal to 0. This ain't that hard. This is awesome. You might want this on the test. I found this in the book someplace. Anyway, I'm setting this equal to 0. I think I'm going to leave the 3/5 where it is. I'm going to move my 4,500 over v squared here. I'm going to sort of multiply by v squared. Is that what I'm going to do? So if I multiply by v squared, it's 3/5 v squared. So now I want to multiply by 5/3. Do you agree with that? I'll multiply by 5/3. That's going to be 7,500 is v squared, I think. Take the square root, please. Wow, what did you say? 86.6025. Cool. Miles per hour. Dude, this is interesting. This is the problem with Bernie's plan. When you pay him $15 an hour, now you do kind of want him to haul ass. Hurry up and get done with his, and then he's going to cause more accidents on the road, you know. This is dangerous. And we're going to burn more fuel and warm up the planet. Yeah, we got a lot of political issues going on here.
Planet ideas. I love it. You gotta have one.
That's cool, though. It's a good problem. You don't have to really get politics into it. You just pay them a wage and you got fuel costs. But you needed sort of the time of the trip. That was kind of key.
That was the key. That's what I
And
put it all together. Yeah.
I guess we'll stop. You come by my office and ask me questions anytime.